Hi there. The topic we'll discuss today from our lecture book will be regarding production choices. So, why studying production choices? On the one hand, both total production but also production in certain sectors are of interest, direct interest to policymakers. So, if you think of total production, that is, of course, representing the GDP. If you want to achieve economic growth, you have to do it through increased total production. And also production in certain sectors, if you think of agricultural sector or manufacturing sector, those can also be of importance to policymakers, especially in the context of development economics. And then the main goal of development economics, as you know, is the well-being of the people, and of course production choices are very important for that. Why? Because on the one hand, it has an influence on supply forces in consumer good markets. As you can see, for example, during the COVID-19 pandemic, where just the fear of disruptions in supply chain can cause panic among the people. On the other hand, producers are also consumers. Why? Because the small farmer will also demand for, let's say, tractors and fertilizers and things like that. But also, he or she might need labor, someone who can help out on the farm, especially during harvesting season, etc. So production choices are also important to determine demand forces on the labor market as well. Another thing that we need to take into consideration, as we have seen earlier, especially in developing countries, many households are also producers, especially in the agricultural sectors. They are running farms or other type of enterprises. So that's why another factor that we need to take into consideration is that those production choices are also important for translating the asset creation. For the asset creation, that goes hand to hand with economic growth. Well, before we start with producer choice theory, we should recognize a few things. One is that you always need inputs to produce outputs, right? In our simple case, we assume that, for example, a farmer needs capital and labor as inputs to produce the output that they are growing. There are, however, constraints by technological options. If you think of the amount of land that a farmer has available, at least in the short term, you can't do any changes in the amount of land, and you have to just deal with whatever you have. Another thing that we need to take into consideration is that if we increase one input and hold all the other inputs constant, yes, we do achieve a higher output, but at a decreasing rate. What do I mean by that? If we assume that the amount of capital is constant and we just add labor, yes, more labor does yield more production, but twice the amount of labor, if we leave the amount of capital unchanged, does not yield twice the amount of production, but less than twice. Another assumption that we have is that producers are profit maximizers, profit being defined as revenue minus costs. So revenue, as you know, is the amount of money that you get in by selling your products, and cost is what you have to spend in order to achieve that output. What is left over is your profit, and farmers are trying to maximize those profits. As I mentioned, we start with a very simple production function. Our production function is here highlighted in gray. Y, which is our output. So our output equals a function of L, which is labor, and capital. So my output is simply a function of labor and capital. I'm going with a very simple production function here, where nothing else is needed besides labor and capital. And we are assuming that capital is the fixed factor. What do we mean by fixed factor? Fixed factor is a factor that you cannot alter in the short run. In the long run, all production factors are always flexible. Indeed, the definition of long run is the shortest amount of time at which no production factor is fixed. So as soon as we have no fixed production factor, so we can alter capital and labor as we wish, we are in the long run. there is no specific limit for long run or short run. So you cannot say 5 years or longer, for example, is always the long run, less than 5 years is short run, or 10 years or 2 years or anything like that. It is a case-by-case situation depending on the nature of the producer. If you have, for example, a farm that you leased for 5 years, and the lease contract is made so that you don't have the right to sublease it to someone else and you can't get out of that contract, then your land would be locked for 5 years. That production factor is fixed for 5 years, which means your long run cannot start before 5 years. So that being said, if you think about it, labor is usually considered as the variable factor because you can hire and fire pretty much immediately in most cases, but capital is a factor that usually takes longer to alter or to change. That's why we assume that capital is the fixed factor. Also, we are assuming diminishing marginal returns to either input, so marginal product of labor, for example, slopes downwards. What it means is that the next unit of labor does not increase the production as much as the last unit of labor that I employed. So that being said, since capital is fixed, in the short run, the only problem that I have as a producer is to focus on the question, how much labor do I need to use and how much output should I produce optimally? In other words, I'm looking for the output quantity that is giving me the highest profit, and then I'm looking for the optimal quantity of labor given the optimal quantity of output that I want to produce. But since those two are linked, as you can see here in our production function, they are both essentially the two sides of the same coin. Another thing that we are assuming that the producer may sell as much of the output as she likes at the price P. In other words, the price P is fixed. As a producer, changing the amount of output that I produce has no impact whatsoever on the market prices. This is true if you are assuming that each single producer per se is too small to have any influence on any market prices. And we have the similar assumption also for the labor market. My decision of hiring more or less labor has no impact whatsoever on wages, and wage is here in our model abbreviated with W, just like the price is abbreviated with P. So in other words, when I want to maximize my profits, as I mentioned before, is nothing else than my revenue minus the costs, and revenue is nothing else than the price of my final product multiplied with the amount of output of that product that I produce. And revenue, if we subtract the costs from that, what we achieve is the profit. Now in the short run, since capital is fixed, it has no influence in my profit maximizing decision. I cannot increase or decrease the level of capital, so that is kind of like my fixed cost. For my profit maximizing decision in the short run, it is sufficient if I subtract the variable cost of production from my revenue, maximize that with respect to quantity, and I would automatically get the optimal quantity of labor for production, because we need to focus here only on variable cost, and the variable cost is simply wage multiplied with the quantity of labor that I am demanding. So as you know, this function is maximized when the first derivative equals 0. So if you take a look here into the profit function, both the revenue and the cost increase with every unit that I produce more. Now the question is, when is my profit maximized? Well, I keep producing more as long as the slope of my revenue function is higher than the slope of my cost function. In other words, with every unit of output that I produce, my revenue increases faster than my cost. In other words, the moment the slope of my revenue curve equals the slope of my cost curve, that's when I should stop producing. Why? Because if I keep producing more, my costs rise faster than my revenue, which means my profit would go down if I produce more. Let me explain this to you graphically. The slope of the revenue curve is telling me essentially by how much does my total revenue increase, and we know that at my maximum amount of output there is exactly one certain number of labor that's associated with that amount of output, which is maximizing my profits. So in other words, marginal revenue must equal marginal cost. Marginal revenue being the slope of the revenue curve, marginal cost is being the slope of the cost curve. Well, what is the slope of the cost curve? Before we look into that, let me just replace output with labor. So we know that given any amount of labor, we produce a certain amount of output, or in other words, for every amount of certain number of output, I need a certain number of labor, which means my profit maximizing quantity of output requires exactly a certain amount of labor, let me call it X, and that amount of labor X is producing the amount of output which maximizes my profit. So let's take a look into the whole thing graphically. As we know, profit maximizing condition is marginal revenue equals marginal cost. Now let's take a look. What is my marginal revenue? Depending on output, which as I explained, output has a direct relationship with labor. It only depends in the short run on labor because the amount of capital is fixed. So instead of output, what we insert here on the x-axis is labor. It's essentially the same thing in a way. It doesn't really change the true meaning of what we are doing here. So my marginal cost curve, which is the slope of my total cost curve, is essentially W. And that was, if you remember, me as one single company. I'm too small to, make any significant changes in the labor market. So me employing more workers wouldn't increase the market wage, or me employing less labor would not decrease the market wage. So anyway, my marginal cost is essentially constant, and that's always W, the wage that I pay for every unit of labor that I employ. What about my marginal revenue? Depending on the amount of labor that I employ, where for every unit of labor that I employ, I can produce a certain quantity of output more. Let's assume if I have 1 unit of labor, I can produce 2 units of output. If I hire a second person, my output does increase, but let's say it increases to 3.5 units of output. Keep in mind that we have diminishing marginal product of labor, meaning doubling the amount of labor. If we keep capital and other factors of production constant, does increase my output, but it doesn't quite double my output. That was the diminishing marginal return of labor. So the first unit of labor, the extra unit of labor increases my output by 2 units, so the value marginal productivity of labor, which then it is 2 times P. Now the second unit of labor that I employed increases my output only by 1.5 units of output, which means the value marginal productivity of the second unit of labor is now only 1.5 times P. Because of the diminishing marginal productivity of labor, marginal revenue curve keeps decreasing. Well, not because the price of my output changes as I produce more, no, but because the marginal productivity of my labor decreases, since we are assuming again that all the other factors of production are kept fixed. So in other words, as long as the value marginal productivity of labor is higher than the marginal cost of the extra unit of labor, which is represented by wage W, I keep employing more and more labor. However, at this point where the extra gain of labor becomes exactly the extra cost of labor, at this point I stop hiring labor because this is the point where I have maximized my profits. In other words, if let's say this is 1 unit of labor, the extra gain in profit, this area represents the gain that I have from the first unit of labor that I employed. And then this area would be the extra gain in profits that I gained from the second unit of labor that I employed. And the green area would be the extra gain in my profit that I have through the third unit of labor that I employ, and so on and so forth. So at this point it reaches 0. Here, this is the optimal quantity of labor that I employ. If I keep employing more than that, the extra unit of labor at this point would cause me a net loss. The extra gain that I have is not enough to cover the extra cost of that unit of labor, which is the wage, and it means it would decrease my profit. So I stop hiring labor after this point, L star. So as you see here, profit is maximized by hiring labor until the value marginal productivity of labor, which was this line here, equals the cost of labor, which is the wage I'm paying W. So let's take a look into the question, what happens actually if wages rise. So if W rises to W1, obviously here at the equilibrium, I employ less labor than before. So L1 is the new amount of labor, and I call it L0, the old amount of labor at the lower wage. So as wages rise, producers use less labor. Now, what happens if prices rise? Let's take a look into that. Well, if prices rise, there's going to be a change in my value marginal product of labor, because that was simply price multiplied with marginal product of labor, which makes it more attractive for me to produce my output. So my profit maximizing quantity increases. In order to achieve that higher profit maximizing quantity, I need to employ more labor. So the level of labor use increases. And if you want to look into the question of what happens when there is a technical change, that is a little bit more complicated, and we will discuss it later down the road.